Good morning everybody and welcome to this morning's webcast on SolidWorks in your industry, focusing on agricultural machinery. So we at Nova Systems, we're a reseller of SolidWorks with award-winning customer satisfaction. We're going to take a look straight away at how we can use SolidWorks for the design of agricultural machinery. Before we do that, we're just going to take a quick look at what agricultural equipment can be. So it's quite a broad industry with varying different sections. So we've got harvesting, grading, conveying, packing, excavation, recycling, washing, planting, sorting and tipping. So there's a lot of different sort of sub-industries, if you like, within agricultural equipment design. So what are the challenges that face companies in agricultural design? So the typical sort of issues that people in that industry will face. So if you're currently using 2D, it may limit the design and visualization of the new products you want to design. Often you'll find that mistakes in design often lead to the rework in production. Everybody's under pressure to complete new projects quickly, so speed is always a factor. Communicating design ideas to customers and suppliers can be quite difficult with the typical 2D tools. Also, the production of service manuals and technical documentation can take quite a long time and requires a large amount of additional work once the machine is completed. It's also an exceptionally competitive marketplace, so ideally we want to try and help everybody optimize margins and get things done faster. Okay, so our customers within the agricultural products industry, just to give you an idea of who's using the tools. So I'll just leave that up there for a moment and then we'll take a look at SolidWorks and how it can be used to help you design your products. Okay, so we're going to focus in on this particular product first and foremost, and we're going to look at a couple of different areas of this to give you a flavour of what can be done with SolidWorks. So the first area we want to take a look at is designing mechanisms. So we're going to create a new assembly and we're going to start just by drawing out very roughly the type of mechanism that we would like to design. So we can do this in SolidWorks quite easily in 2D. So not dissimilar from AutoCAD, but there's a couple of things I want to show you here that will really help. So the first thing I'm going to do is just draw out a piece of box section just to give us a sense of scale in what we're doing. So we know that we're going to be using 100 by 80 for the bits and pieces that we're doing. We can very quickly turn these into blocks in the system, and as a block it can move around wherever we want it to be. So I'm just going to place that down and just make that horizontal there. So we want to sort of make a mechanism for the tines to lift up here. So the next thing I want to do is just draw very quickly just some pivot points that we're going to use. So we can do this using the sketch tools in SolidWorks nice and quickly. You'll see that I can translate to an arc quite simply and then go back to a line. So I've created some pivot points there. We'll just stick some circles down on there just to indicate what they are. And then again I can turn that into a block by using Windows Select or using the Control key on the keyboard just to grab hold of bits and pieces. And again this item will now have the ability to float around and we can place that and relate it to the neighbouring component nice and easily like so. So the next thing I want to draw out is again just a simple sort of rectangle. We'll give that a dimension, so we want that to be 450 mm long. And I can use a centerline tool here just to place an axis on that. And if I want to, I can stick a couple of points down on this here. So just indicating where the pivot points on this section will be. So we can place those down and just give those a dimension as well if we want to, like so. And again we can turn that into a block just by Windows selecting it, grabbing hold of it and telling the system we want to make that into a block. What I can now do is relate that to the pivot point, and you'll see now that I've actually got movement in my system. So off the bottom of here is going to come our sort of time that we're going to be using, but I want to connect up this point and this point together with a hydraulic ram. So we can draw out the hydraulic ram, again very quickly and very easily. You may know the size of these whilst you're doing the mechanisms, the size of the unit that you're actually going to want to use. We're just going to draw it roughly out just to give you an idea. So we can turn that into a block, and again just relate that to that pivot point there, and we can now draw out the inside of the cylinder as well. So we'll just make that a little bit thinner just to make it a bit more realistic, like so. Again, we'll just use a centre line and a couple of pivot points on. Actually, we probably don't need too many pivot points on that one, so we'll just turn that straight into a block. So now I can pin the end of that to there, like so, and then I can tell the system that that line and that line are what we call collinear. So now what we end up with is the movement that we would expect from a hydraulic cylinder operating that sort of linkage that we've got designed there. So we can see quite early on within the design process that we may end up with a clash depending on how high that's going to lift up, and also what kind of travel the cylinder is giving us and whether or not we've sized that appropriately. Just remember that we've sort of used some, not even any dimensions there, we've just sort of roughly sketched that out, but it gives us an idea of what we can do there with sketch block design. So that's a really nice way to work with mechanisms and mechanised functions and see how they're actually going to work before you start committing to designing anything. So the next thing we'll do is we'll take a look at how we can create some 3D geometry. So I'm just going to start a new part and we'll go ahead and get sketching within this one as well. So what I want to produce is a framework for a section of the design. So we're going to start by drawing on a plane here, and we've got some nice sort of customization within SolidWorks that we can do. So we can click an S key and get access to all the sketch shortcuts that we want to use. So I'm just going to use some center lines here and roughly draw out, not necessarily for size, I'm going to add some dimensions on now just to size that up. So we want that to be 250 mil high and 1280 between. I'm going to exit that sketch and actually just draw in some 3D sketch lines now. We're actually wanting to position some bits of steel just to create our framework here. So I'm just using the sketch tools just to draw out 3 lines. I can make those all equal in terms of their length using the relationships, and then give those a dimension that I want to use there, like so. And I can connect those up at the other end if I need to, just again by using the very simple sketch tools within the system. So my framework is going to be based around some structural members and within SolidWorks we actually have a library of standard sort of stock steels that we can use. So this is using a piece of functionality within the system called Weldments. So if I tell the system I want to use a weldment, I can select from varying different standards. So we're going to be using the BSI standard and we're going to use an RHS, and we actually want to use an 100 by 100 by 6. So you'll see that we've got quite a comprehensive library of these sizes available to us. You can add more to this library as well, so that's something that we can do very, very quickly. Once we've selected the size, all we need to do is pick on each of the entities that we want that beam profile to be along, like so, and we end up with our steels on the screen. You can make changes to the original sketches as much as you want to. So here we could change that 1280, for example, to 2700. You can even type in 2.7 and put an M after it, and it will convert that through to units. And if we just rebuild that, you'll see that it extends those structural members along for us. So we have the ability to go back and change very, very quickly. What I now want to do is put in some plate steel that connects these structural members together. And we actually want those inset from the outside face by about 500 millimeters. So what we can do there is we can actually create a reference plane inside. So I can drag off a reference plane like so, give it a dimension of 500 millimeters, and that plane now intersects those structural members at that point. So I can now start a sketch on that plane if I want to very quickly and start producing some sketch geometry to link that together. So again, we can use our line tools here, and we're just going to use some existing geometry to sketch that out like so. We'll do this roughly first, and then we can add some dimensions on to control it in a moment. So I'm just sort of linking to the structural members that I've already got and drawing out, as I say, quite roughly what I actually want to create. So you'll see that I've got the rough shape. If I want to relate to any existing geometry, I can just use my relation tools here to make those collinear, so those lines actually touch the structural member. And you can also drag the points up and down if you want to, and link to vertexes or any other piece of geometry that you want to snap to. So again, this can be really quick. We'll just snap that point down there, and we end up with our sketch, which we can move around and adjust if we need to, like so. So I'm actually just going to pin some dimensions to this now to control the sizes. So we want that to be 50. We want an angle here of 25 degrees. We'll make this one just come downwards like so at 5. We'll give this one 12. And we'll just set that down from that centre line. So you can see I'm actually using a centre line from another sketch here just to help me position these items. Just using angles and dimensions to control the position of that geometry. So you can see there in 3D what we end up with, and once we've actually drawn something like that out, it's very quickly for us to just use an extrusion and specify a depth for that to be extruded either internally or externally, depending on which direction you want it to go. So you'll see now we end up with our plate on the inside. Now if that's going to be laser cut or water cut, we may want to actually fillet some of the corners. So we can do that really nice and easily using the fillet tool. So you can actually just select an edge if you want to and start the fillet tool directly from there, which is a real time saver, and then we can just fill in a dimension and select any additional edges that we want to add. Now when you select additional edges, we also get a little fly out here which will allow us to grab hold of some common selections, if you like. So here this is actually going to select all the vertical external edges for me, and I can click the button, and if we just resize that to about 25, maybe 15 if we say, you'll see we get a preview of all the corners that are going to be filleted, so it gives us a nice rounding on each of those corners very, very quickly. And we've got our plate sort of sketched out. Now there is a level of symmetry in the design that we're working on at the moment, so we would want one of those plates over on the other side. So we can mirror those about a plane over to the other side. So in order to do that, I need another plane in the center, so I'm just going to use my right plane here and create a reference plane from that. Now we know that the length of this is 2,700 millimeters, so we could just half that dimension and type a dimensional value in. But what you can also do is select items from the geometry. So here we can actually select the midpoint of that structural member for us to create our reference plane on. What that means is if the length does ever change, then that plane is always going to remain centrally located. So we can then use that plane and mirror our item over to the other side. So we end up with two of those linking that together. Because this is an agricultural product, we may not want to have open-ended caps or not have open-ended sections to our profiles here. So we can use within the functionality an end cap tool. So I can come onto this face here and select the end cap, and I've got nice granular control about how I actually control the position and thickness of this end cap. So we can make that 10 mil, for example, and specify that it goes internally, so it's not actually affecting the length of my assembly at all. We can also specify some ratios here to make it exactly the same dimensions as the profile that we're applying it to, and we can also chamfer the corners as well, just by selecting a dimensional value, just so we cut off for those fillets there. Once you've specified your options, you can go around and pick any additional edges. We've also got some really nice tools like the magnifying glass within SolidWorks to allow us to grab hold of smaller faces a lot quicker. So here we can use it from quite a distance and actually zoom in with that magnifying glass, and it will just help us select those faces without having to manipulate ourselves around the model a huge amount. Okay, so we've now placed our end caps on. So the next stage for us is just to create some other extrusions that we want to include on here. So we're going to have another reference plane created from this end face here at 300 millimeters, and that wants to be internally, like so. These planes are infinite in terms of their size, but we can drag those out, make those a little bit bigger visually if we want to. We just want to draw out another extrusion onto that plane now, so we'll just take a look at how we can do that. So again here we can just use our sketch tools very quickly just to sketch out roughly what we would like to have. So again, I'm not overly concerned with dimensions at this stage because we're going to add those on in a moment. So we can use a combination of dimensions and relations. So here I'm just going to make sure that that touches the top of that structural member, and the end points here intersect either side of those as well. You can do this really quickly just by holding down the control key, which will allow you to select multiple entities. So here we'll just pin some dimensions on this, like so. So we can just use our dimension tool. The Smart Dimension tool is really clever because it will give us angular dimensions or length dimensions depending on how you want to, on what you select and how you want to control that. So we'll just go around here and just finish off the positioning of this. What you can also do while you're doing this, you'll notice that the sketch is actually blue because it's underdefined, so we can still drag that around and resize that if we want to and see where the movement exists in that sketch that we've created. So I'll place that down at 80. Now we've seen the fillet tool for solid geometry, but we can also use a sketch fillet tool as well. So we can select that from the sketch toolbar and then actually position some fillets at a certain size. You can use a window selection here just to grab hold of those corners, or alternatively select the two lines that you want to fillet between, and a right click will just confirm that you're happy with what's selected. So we've got our plate drawn out. Again, we can apply an extrusion to that and extrude it in a particular direction. So we want that to go externally this time, and we add that in like so. Now at the moment that plate is actually cutting through this structural member here, so what we really need to do is clearance this plate for those items. So we can do that really easily by actually just copying some of the geometry from that face. So we're just going to select that face there and use something called Convert Entities. So we'll do that on both of these structural members, which will actually just copy the size of the face onto our plate. We can then use that as a cut and say that we want to go down to a depth, and then we can specify that we only want to cut that particular plate, like so. And if we just isolate that just so you can see in a bit more detail what's happened, you'll see it's clearance that plate for the structural members that go through. The really beneficial thing about working in this way is that if we do decide that we want to alter the size of the structural steels at a later date, that the profile that we've used to cut out will adjust automatically to the change in size that we've made. So what we can also do within the system is actually pattern bodies. So we're going to pattern this item here along a little bit. So we only want 2 of those at the moment, and we want those to be separated by a distance of 80 millimeters, like so. And we end up with 2 of those. We can also pattern patterns as well. So we could use another pattern here and say that we want to actually pattern these 2 items, and we want those separated by a distance of 700 millimeters, and we want 4 of those along the length, like so. So we end up with our multiple entities shown across as we have on the screen. Okay, so while we've been working on this file, SolidWorks has been doing a few bits and pieces for us in the background. We'll leave this as it is at the moment, just so we can focus on some of the other functionality within SolidWorks. So the first bit I want to talk about is when you're working with structural steels and plate sheet metal, we can actually have something called a cut list generated by SolidWorks. So over on the left hand side we can see the cut list, and it lists all the items we've got within the file. What we can do though is we can actually update that list, which will categorize each of the items, have a look at them and see if they're exactly the same, and then put them into a folder so that we can see what quantities of each component we've got. We can also create what's called a bounding box. So if we look at these pieces of sheet metal, they're going to be probably lasered out, but we may want to see what the envelope size of those actually is. So we can do that just by a right click option. If we save this component away, we're going to call this frame. What we'll do is we'll just take a look at a 2D drawing now. So typically there'll be your communication tools with manufacturer or with subcontract manufacturers, so we still need to create those, but what you'll see in SolidWorks is they're really quick to create. So we can create a drawing directly from the part file that we've created. Over on the right hand side we can see some of the default views that we can use within our drawing. So here I can drag out a right view, populate a top view, and then drag out another view there, and maybe have an isometric view shown in the upper right hand corner. We'll just turn our sketches off there just to make life a little bit easier. So you can see very quickly we can generate the views for the typical views that we would use in 2D. What we can also do, which is really nice, is actually produce that cutting list and display it on the drawing. So very quickly we can insert that cutting list just by selecting the view that we want to use and placing it down on our sheet somewhere appropriately. And here we can see actually the information that we can gather from the file. So the first thing that's worth pointing out here is that we've used some standard box section steel here at 100 by 100 by 6, and it will give us the length and also tell us the quantity of how many we've got. And the same applies for the plate work that we've got in the drawing as well. That will give us an overall sort of blank size, if you like, and tell us the quantity that we're using. One of the other things we can do to aid sort of manufacture and just help people visualize exactly what they're looking at is actually balloon each of those items on the drawing as well. And these balloons are very intelligent, so if we move that balloon onto this item, for example, it will change the numbering to reflect what it's actually pointing at. So these balloons are directly linked to the table that we've already inserted. So we might want to move that one just over to this side view here just so we can see that in a little bit more detail. We can also show that in colour, for example, as well if we wanted to. We may want to be a little bit more realistic with our colouring, so if we just return to our part file here, some of the other things we can do within SolidWorks are actually apply materials to components. So within the system we actually have quite a comprehensive library of materials within SolidWorks. So for this particular component we could say we're using an alloy steel, and you'll see that all the physical properties for that material are actually shown within our database as well. So we can apply that steel to our component. The first thing you'll notice is that it colours it based on the material that we've selected, like so. And if we turn on what's called real view graphics, we can get some quite nice reflections on the component as well. So we can really visualize exactly what it's going to look like. One of the other benefits to adding a material to a component is that we can get things like the mass properties. So if we just change this into kilograms for mass, we can actually see that our component here weighs 238.86 kilograms. If you are interested in centre of gravity on your components as well, we can always apply what's called a centre of mass in SolidWorks as well, so you can actually see where that centre of mass is while you rotate around the component. If we return to our drawing, you'll see that the colouring will come through over here as well, so we can display that in our drawings. Now we may want to apply some dimensions to our item as well, and we can do that very quickly just by using some standard dimensioning tools. So you can place on just general dimensions like so. We can also actually reuse the dimensions from part level as well. So it may sort of add quite a few dimensions to the drawing that we're doing at the moment, but it's quite a quick way to get a load of dimensions that you can actually remove any duplicates or things that you don't want on there. So we can say to the system that we want the entire model's dimensions into all the views and just click the green button, and we should end up with quite a few dimensions on our screen here. So we may want to remove some of these just to tidy up what we're doing. So we'll just get rid of some of these angles here just so we can see what's going on. But you can see that we can actually populate our model very, very quickly. One of the other things that you may like to do is actually draw out particular views of the sheet metal components that you've put in. So we can actually do what's called a relative to model view, and we can say to the system that I want a drawing view of this item, for example, and I want that to be my front view and my right view to be that one, and just add that straight into our drawing there. So we can scale that specifically based on how big we want it to be. So we could do that at 1 to 2, 2 to 1, for example, or maybe 1 to 8, just to give us an idea of what that looks like. So you can do things like that. We can also do detail views as well. So if you wanted to be a little bit more specific about some detail in this area, for example, we can actually draw a circle around it, place it down on our view, and actually get that shown in a higher level of detail. One of the things that's also worth pointing out is if we go back through to our model, we mentioned at the start that if we change dimensions, everything will update. So here we could make a change to the width and say we'll make it 3000, for example. So we can update our 3D model like so. So you'll see that our leg has come out past the position of this item here. If we actually go back through to our drawing, you'll see that each of the views is updated to reflect that change that we've made. What you'll also see is that the length is adjusted for the length of the structural steels as well. So everything is related together. So that dimension there is now 2980. If we went back to our 3D model and just adjusted that back to the 2700, like so, and return back, just so you can see the updating of that table, that's now 2680. So that's fully up to date. So a really nice way to speed up the process of your design, especially if you're working with tools like AutoCAD. You know, we've got 5, 6 views of that drawing there on this one sheet. If we'd have made that change in a system like AutoCAD, we've had to remember to alter every one of those views. So that can be quite a time-consuming process, and also quite prone to errors as well. Okay, what we're going to do now is we'll take a quick look at how we can assemble components together. So we've got sort of half an assembly open at the moment, and we're going to start assembling that with another couple of sections just so we can build up a little bit of a design. So what I'm going to do is I'm just going to place that into another assembly. And we can also bring in other assemblies into here as well. So you can see here I can place this assembly in as well. Just turn off our annotations there. And we can rotate and move this around as much as we want to. Our job now is to relate the two together. So this is actually a top section that fits on here, and it should be connected by two link components that will allow it to move. So we're going to bring in that link component now, and we can start just relating the two items together. And we use a system called mates in SolidWorks to do this. So if I want those two to be in line so the linkage actually works, what I can do is I can select that inside face there and also the inside face there, and I can use what's called the coincident mate to relate those two components together. So now what we've got is that completely in line. It can't move off that line. It can move up and down and around, but it can't move off that line. So now what I'm going to do is I'm going to just use the cylindrical center of that and relate those two together using a concentric mate. So we can see that that can move up and down, and we want that to be inside that gap as well. So what we can then do is use a mate called width to actually position that centrally. So all we need to do is just pick the faces, and we'll just go around and select the other faces that we want, and then also the faces of the gap we want it to be in between as well. So that's going to be that one and that one there, and you'll see that positions that component directly in the middle of that gap. You can see here how we can actually allow movement as well. So we've reduced some degrees of freedom for that component, but we've still got a rotational degree of freedom left. So we would now want to link that to there with a concentric mate, and now what we'll see is we can actually just come out of the mate tool there. We can actually move that up and down like so. So you can start to build up live mechanisms using this mate functionality. So we're going to want another one of those linkages on the back side here. So we can just drag another one of those in, and we'll just do exactly the same thing. So we want to relate those two together with our concentric mate, and we're also going to want to use a width mate between the two faces, again just to position that properly. Like so. And again, we want that just to be linked at the top end, so we're just going to select those two faces and apply our concentric mate again, like so. We could do the same on the other side, but just for the sake of speed, we can see what we're actually creating here just by moving that up and down, just to show you what that movement is. One of the other really nice things that we can do in SolidWorks, we can drag the components around, as you can see on the screen, but we can also use something called collision detection. So we can actually start to detect where collisions occur within our system. So if we turn on the collision detection and drag that component again, we can actually hear a noise and see what the upper extents of the movement of that mechanism actually are. So it's a really nice way to validate whether you've got the lengths of linkage components correct, or whether you're interfering in the place that you expect to interfere. So a really nice way to do that. Again, we can show the centre of gravity on assemblies as well, so it's just a question of inserting that centre of mass, and we can see where that is. And if we start to move and manipulate the components around, we can see the change of that centre of mass as we're moving the components. We've seen how we can generate what's called a weldment cut list from part level, but we can also create a bill of materials at assembly level as well. So we can just insert a bill of materials into this, into our assembly here, and we'll just place that down, and we can see the number of components and the quantities that we've got, and effectively take a look at our build list very, very easily. This can be displayed on our 2D drawings of the assemblies as well. So, you know, it can be placed in the 3D model or alternatively at 2D drawing level. Okay, if we just return to our top level assembly that we've got here, showing our full assembly, we can see that that's looking reasonably realistic on the screen at the moment, but we may actually want to create a rendered view of that for marketing materials or to show a customer exactly what that looks like. So within SolidWorks Professional we can actually use a rendering solution called PhotoView 360. So appearances are applied from the right hand side from a library of appearances. So for example here we've just used a yellow paint on our objects here, but we could easily drag out another colour, for example a red, onto some of these components, and you just drag and drop and position that on the component that you want to be in that red colour, like so. So we can do that at part level, assembly level, and just colour everything as we want to. We can also turn on perspective for a more realistic view, so we can give the component a little bit of perspective, and you can focus in on certain areas however you want to, so position your component as to how you want it to display. Once we're happy with how it looks, we can take a look at a preview of what that's going to render like. So at the moment what we're seeing is the graphics card displaying the visual properties of that assembly, but when we do a render what we're going to do is use the CPU to generate that. So we can start to see that generating the image that we're looking at. So you can see that we get some really nice reflections and quite a realistic display of what that looks like. So once you're happy with the preview render, you can actually go ahead and render that. Depending on your settings and how big your image is, that'll take sort of between 20 minutes, you know, maybe an hour, that kind of thing. So not overly long by any stretch, and we can get some really, really nice images there to show people. One of the other things that we spoke about at the start was technical publications or service manuals, and there's a number of ways that we can do this. So if we take a look at another sub-assembly here that's made up of a load of components, one of the things that we can do is we can create exploded views. So these are really easy to create. Once we've got an assembly, all we need to do is select components that we want to explode and pull them off in a certain direction. So you'll see here that I can grab hold of those items, for example, move them out of the way. Maybe we want to look at this bottom section as well on how we move those around. So here we want to align that to the origin, so we can move that out like so. We'll do the same with this item and move that out, and we could take these washers and just drag those out. You can be much more specific than I'm being at the moment with actually how these components come out and in which direction, how far, that kind of thing. But we're just sort of being reasonably quick about what we do. So we've disassembled some of that component, and we can store that away as a view that we can use in our drawings, or alternatively what you can also do is we can actually create an animation. So we can show how all of those components go back together, loop that round, which is a really nice way for people to see how things are assembled or things are replaced. Once those animations are created, you can actually save those animations away, send them to somebody via email. Or alternatively what you can do is you can use a system called eDrawings. So some of you may have heard of eDrawings before. It's a free download from SolidWorks, and it will allow us to send 3D models to people so they can view and see what they look like. The really nice thing is that they actually include the exploded views as well, so we can start to see those exploded views, and you can also animate those within eDrawings as well. So all that information you've created in 3D can be really powerful to show somebody how a product goes together, and also for manufacture on the shop floor as well, to show the guys who are assembling these products actually what they need to do. You've also got some nice play buttons here which will animate us between the views. You can stop that at any point and use a standard rotate tool, start to zoom in, get some information about the components from the assembly tree in terms of part numbers, things like that. You can use the select tool, hover over items, and it'll tell you what they're called. So a really nice visualization tool that is free and part and parcel of what we do in SolidWorks. Okay, so we'll just switch back to our PowerPoint and we'll just sort of talk about what we've seen. So we've seen some really nice ways to create our part documentation, from sketching out mechanisms to then creating some 3D geometry, our 2D drawings. We've then taken a look at how we can assemble components together with movement, how we can analyse for collisions and check the functionality of those components. We've also taken a look at how we can generate exploded views and also communicate that information with people who haven't got a 3D modelling tool or SolidWorks. Okay, so just to close off, here's a nice visualization of an agricultural product. So we've talked briefly about the visualizations and also the welded frameworks, but we can also do sheet metal within SolidWorks as well. There is a lot more to the system than we've seen today. It is quite a brief introduction to what we can do with SolidWorks. But if you do want to get any more information, find out about how you can purchase SolidWorks, then please give our sales team a call. There are some future webinars that we're going to run. We run them every Thursday, so you can have a look at our website and see which ones are upcoming and whether or not they're of interest to you. Thank you very much for watching. So we do have a couple of questions actually, which I'll just respond to now. So one is, what's the price of SolidWorks? So we start at around the 5K mark for SolidWorks, so a sizable investment, but there is a lot that you can do with the software, and it does bring a lot of benefits to a lot of people. Somebody's also asked, how long is the training? So good question. It does depend on what you're wanting to do with SolidWorks, but the standard training course that we run here is 5 days. We tend to split that into a 3-day and a 2-day, but that'll go through all the basics of SolidWorks, how you use it, how you create your parts and assemblies, link them together, and also how you create the drawings as well. You can do additional training in certain areas of the software, so specifically sheet metal. If you were into consumer product design, for example, we do a surfacing course. We also do some courses on the simulation products as well, so there's quite a varied range of training that you can do, but generally for new users the standard essentials course is 5 days long. Okay, once again, thanks very much for watching. If you do have any questions, please do give us a call, or alternatively use the email address towards the bottom. Thank you very much.